Hi everyone, welcome to the University of Manchester. We are the Control Estimation and Human-Robot Interaction Research Group here in the University of Manchester, and we're very happy to show some of our work in human-robot interaction, control, and interface design. We're here with my colleague, Dr. Hanley New. I'm Ernie Lopez, and also Neil and Winchi PhD students will help us showcase some of our research. We'll show you a VR-enabled human-robot interaction interface to control an industrial robotic manipulator. I hope you enjoy it. We'll show you first some of the setup. We'll explain some of the technical bits, the interface, and then we'll show you how it works. Hope you enjoy it. I will go now and show you what's the robot setup. We'll be right back. So today we're working with a UR5 or Universal Robot version 5. It's an industrial robotic manipulator equipped with a gripper. This is very common in industrial applications to pick and place. This setup will be used to showcase a task called grasping and manipulating objects, such as these two bottles. Besides this setup, we have two webcams, which we use to give additional information to our human operator or human user. And now I'll show you what we call our VR interface for control. So we are here with our colleague, Dr. Hanley New, and he's going to use a VR headset similar to the ones in gaming applications. And inside, you're going to see the VR representation of what I just showed you. So there's a 3D simulation of the robot. So Hanley is going to use the VR headset to see this representation. And together with a sensor that you see here, well, it's called the leap motion, we're going to use our bare hands to move the robot around. What we're going to do is to move what is called the end effector, or the last tip of the robot. I'm going to move it around in order to grasp and reach to different objects. So, Aline, whenever you're ready. Thank you. Yeah, so you just saw a video of what's the virtual representation of what Hanley is looking inside the VR headset. And as you can see in the video, Hanley is just moving his hand, and the robot it moves around just the last tip, or the end effector, as we call it. He just grasps it in the air, moves it around, and when he's ready, we do the grasping and the reach motion. This is all designed automatically in the sense that we are not moving each limb one by one. We do the calculation, the mathematics for it to be moved smoothly. And the grasping is also automatic, but right now for demonstration purposes, our colleague, when she is doing the grasping. But all the motions are done exclusively by Hanley. As you can see, we can move it in all three directions, X, Y, and Z, and we can also change it in orientation, as you can see. It's a fairly easy interface. It just takes around 10 to 15 minutes to use it. It feels almost like a game in the sense that it's quite interactive, it's very friendly, and it's quite robust in the sense that if there were to be any problems, disconnection or something like that, all the motion and the forces of the robot will be clamped. Hence, it wouldn't just move around and crash. As you can see, he's moving from one bottle to the next. And when he's ready, he just moves it around, goes lower, down, and grasps it. If you see Hanley moving his head to the left and to the right, is because that's where he would see the webcam feedback, or the webcam streaming the video, so he can have more information about the environment. And these type of applications are very interesting because we designed them to be safe, in the sense that this is basically replacing a human being who will be interacting with dangerous substances or in harsh environments, all of our work here in Manchester, mostly in the robotics area, is in the nuclear industry to support already legacy construction and improve performance of all the tasks and all the processes, but primarily for safety reasons and for operators to be safer. Yeah, as you can see, you can move all over the workspace, as we call it. And you just move it up and down to all directions. Our idea with these interfaces is that it can be a novel way to interface with a robot. We don't need to use a joystick or a physical device. Although they are very useful and they're being implemented in industry for a long time, hardware components were down, and sometimes it's difficult to maintain and support these devices for more than 10 to 20 years. So that's some of the challenges that we face. Creating interfaces that can be used by almost everyone with sufficient training, but that can allow good and safe operation. Hopefully in the future, we will use this in applications that are called glove boxes. These glove boxes will be in a normal setup what a human does when he puts his hands into shielded gloves to manipulate dangerous substances in nuclear civil plants. And as you can see, this would be an interesting alternative to implement these things. So Hanley is going to be moving the robot around a little bit more. But if you have any questions, please put it in the chat. We'll be here just replying or anything. If you're interested in robotics, control estimation, and all the things that come with this, especially AI, machine learning, all these very interesting topics, just come here to University of Manchester. We're more than happy to talk and to share our work. If you have any questions, please put it in the chat box. We have Neil and Wincy replying to questions, and I'll also see them here right in the down bracket. Just some comments about the interface. It's quite entertaining at the end because it gives you a lot of control to a robot that usually is difficult to program. Well, when I say difficult, is that you need to know either what you're doing for the interfaces of the control, but you need to know a lot of the mathematics. So Sam, thank you very much for your question. What does the operator see in the VR headset? So this is what he's looking at. That's his view, basically. So he sees this 3D simulation of the robot. And as you can see in the bottom and in the front panels, those pictures that you see there, those are the live feedback. So as you can see, when he starts moving, the images change. So those two video feeds are superposed to these planes. And that's a way for him to have more information because, fair enough, you have the 3D simulation and you see what the robot is, how the robot is moving, but you don't know how close or how far it's from the object all the time. And this video feedback helps you to have more information. So yeah, I hope that answers your question, Sam. Thank you very much. Ahmad, thank you for your question. How to control the force? Well, that's a very interesting question. Usually, we're bounded by the capabilities of robots, meaning that some providers allow you to do only position and speed control, meaning that in the low level or the low layer of control, they do all the force, but we can only give them position feedback and position set points. That's what we have here in the UR5. But other robots like the E-series of the universal robot, KUKA, Kinova, you can control the torques. However, what you do in those cases, if you cannot go directly to control the torque, you have models that estimate the torque that you would apply by setting the position. And that's something similar to what we do in our packets. I hope that answers your question. If not, then please go back again and we can just chat more and give more detail about how it works. We have the setup there. although VR is very entertaining and it's very useful, as we're going to have 4 demos today, we're trying to compress our time whilst moving the object. The VR technology is bounded by refresh rates and latencies, and it can be tiresome. So that's one of the hindrances of our setup, but it works very well, as you saw right there. Some details about the problems that rises when you have this type of application. As time goes by, maybe 2 decades now, it's easier to just move the robot around. It's not even mathematically complicated in the sense of you can have a lot of control in that. However, when you have environments that are called dynamic environments, so things move around the robot, you need to have more knowledge, like with sensors, to know if you are hitting an obstacle. That's one of the problems that these applications have, besides also the grasping itself. It's very different to grasp a soft object, a hard object. There are different geometries. You can have different angles to reach the object. And although it seems easy and intuitive for us, we are extremely advanced, extremely sophisticated, beings. So we do that fairly easily. But for robots, it's not that easy. Although there's many challenges still ahead, there are many technologies like deep learning based and control based to grasp different types of objects. We do some of that research here in the University of Manchester. Have any other questions, please come back to us. We'll put the video again in loop in case somebody has some questions. Somebody could ask when the video is there, why did we use an Iron Man head for the visual avatar, meaning that will be the head of Han Lin. So he's looking down there. It's just for fun, really. So everyone, thank you very much for joining us. It was basically the demo for human-robot interaction interfaces. If you want to keep chatting, you have some other questions, well, feel free to put them in the chat. We'll be here online, but we'll just continue feeding this video until we have some other questions, and we are here happy to engage. And hopefully this is either challenging and inspiring for some of you, and if it's very boring, well, there's also a challenge, make it more interesting. So yeah, thank you very much, and hope to see you soon. So we have some questions. Massen619, thank you very much for your question. How can you minimize the delay when handling moves, his hand and arm moves? Well, that's actually a very interesting question. And our work primarily is designed for long range operations, meaning that even if you don't see the cables here, we are connected through Ethernet, but we've done it through different cities, and we've done it from Edinburgh to Manchester all over. There are many problems from the networking itself, as you can imagine. Even now, you don't see what I'm doing directly. We have some delay. But for control purposes, the main key issue is not so much delay, but jitter. Meaning is that if you know that each control signal is moved in the same point with the same time between each one, it's easy for you to have smooth motion and controllable motion. But if sometimes the signal is faster, now slower, faster, slower, that creates some jitter. So there are some techniques that you can use for control purposes for when you design it. That's what we research. Other people do it more from the networking part, and they just put a bigger cable. So they go from 3G to 4G to 5G and so on. But there are other ways to do it. We try to do estimation of delays. Other people just put a bigger tech cable or do data compression as well. So there are many ways to go forward, and there's not a single solution at the moment. But yeah, it's an interesting question. If you have more, Mazen, please come back to us. And thank you very much. Hi, everyone. So again, thank you very much for being here. We'll keep showing the demo another 3 times. So if you want, just pop back in here in a couple of minutes. Thank you very much for joining us, and I'll see you in 10 minutes. Thank you. Hi everyone, it's me again with another question from Jung Yang. Jung Yang, thank you very much for your question. May I ask if there are any position tracking error between the virtual arm and real arm? How to deal with disturbances in the real working environment? Well, Jung Yang, that's a very interesting question. Is there any tracking error? We're basically trying to drive the real robot's movement and motion from the virtual one. But we do have some loop there, meaning that we replicate them. We try to avoid it in the sense that we are working in the real environment and everything is being replicated in the 3D one. So that chucks down the error. Additionally, some good calibration in the beginning also helps because at the end we are working on top of a controller, which is the position controller. That's another problem that we can have. And disturbances right now, our strategy is more about the sensory augmentation from cameras. Handling works a lot with 3D point clouds. I work in the estimation part of motion as well, so that helps. But there's not one unique solution because at the end of the day, you need to work on top of a controller that's already there, which can be tricky. As you can imagine, most of these controllers have a lot of PID loops or traditional control loops, and you're working on top of it. So what we do is sensory augmentation. You can have a better robot, or you can have low-level control, and that helps immensely. But our strategies right now is basically trying to drive everything from real back to the virtual. I hope that's a good answer. Julian, if you have any other questions, please go back and say, no, I want more detail. But anyway, thank you very much. Oh, Claire, thank you very much for the question. Yes, let's see what some people experience motion sickness when using VR. Yes, you're completely right. Have you ever had this problem, and is there anything that can be done to help motion sickness robot operators? Well, Claire, thank you very much for your question. That's absolutely right. Right now, for the VR universe or the people that work on this is an extremely important issue to deal with. And the VR people, the ones that design the headset, always try to get some rule book of what we can do to avoid this. For instance, have a high frequency rate, the calibration of the eye distance from the foveal retina, using more advanced VR headset, because as you might imagine, in the last 5 years, technology has grown immensely. And basically also something related to the frequency of the refresh rate and the control rate. Meaning that if it's too dissimilar your motion with what you see, you also activate this type of thing. However, from the control perspective, what we're trying to do is that it feels and looks smooth, but the VR part, which is the display, is something that we, at the moment, are not working on. We just use a better kit. However, I can say that there's a lot of research into how to make this better. I myself get a bit motion sickness of this. I cannot even play a FPS game without getting a bit motion sickness. But then again, not everyone does. So there's still a lot of research into how to fit and to improve all the experience. And the last thing I want to say, technology that is very useful now, and this upcoming new VR headsets, is eye tracking. So if I'm tracking my eye position and how I'm moving around, I can adapt what I'm looking at in my screen, meaning that it's more clear or less clear. And that is supposed to help a lot of these motion sickness problems, meaning that I just adapt myself to how I'm supposed to look in the screen. I hope this helps, Claire. Thank you very much for your question. You can come back in any time. Oh, Alia, thank you very much for your question. Let's see. What types of feedback are available for the user? Is it possible for the user to feel objects they grasp in the virtual space? Alia, thank you very much. It depends on the device and the interface you're using per se, meaning the device. Right now, the VR headset, it has audio feedback and visual feedback, right? Meaning that if we connect things correctly and design our interface, I could see more feedback on the visual. I could put audio feedback, meaning a beep or a sound. I've experimented with this a lot, and sound feedback is amazing for inclusiveness and immersive feeling. But also some controllers and some hand interfaces do have vibration and even haptic feel. So it depends on the device. It's not a plug and play problem. You cannot just plug it and it works. But yes, you could have the feel and motion of what it would be to move an object. Of course, you need to model the object, you need to estimate how it would feel, and you need to put that in the device. We've done that with some gloves, haptic gloves, but that can also be done. You could also have a full motion platform that induces more motion sickness. This would be for driving simulators or pilots. But yes, you could do that. However, it has some, well, challenges, let's call it. Alia, thank you very much for your question. I hope that makes sense for you. Yeah, grasp in the virtual space. If you have any other questions, guys, please come back to us. We're more than happy to reply and always discuss these things, because we do a lot of research, which is have designing and developing things like in a company, but also think about the next questions, the new thing to come to drive scientific knowledge. So even that question about the interfaces and how to do things better is still very much an open question for this full dive immersive experience. So yes, thank you very much. If you have any other questions, please pop them in the chat. Hi everyone, welcome to the University of Manchester. We're here in the Sackville Street building, Lab D9, and we are the Control Estimation and Human Robot Interaction team. We're here with Hanley New, my colleague, and Mervyn Lopez, and as the supporting staff, Neil and Winchi, PhD students. And we're very happy to show some of our work and some of the outcomes of our research. We're going to show our VR-enabled teleoperation setup to control an industrial arm or a robotic arm. So let's go, and I'll show you our robotic setup. Hi everyone. So this is our robotic setup. We have a industrial manipulator from a universal robotics company. It's called the UR5. We also have a gripper, a grasper from the company Robotics. Is the 3Q, and we're going to showcase how we control and move this robot with a very special interface to grab and move these bottles around what we describe as the working space. Also, in addition, we have two webcams, one positioned here and over here, to give the human operator more information about what is going on in our space. So after showing you this, I'll show you our design VR interface. So let's come with me. So we are here with our colleague, Dr. Hanley New, and he's going to showcase the interface. It's basically a VR interface where we use a headset like this, like a headset for gaming, a VR headset, and inside he's going to see a VR 3D representation of what I just showed you. So he's going to see a 3D robotic arm with a gripper, and he's going to control that gripper with his bare hands. So what he's going to do is he puts his hands in front of his face, and with the sensor right here, it's called the lead motion, we get the hand position, and he can just move it around. So Hanley, whenever you're ready, thank you. What you just saw in the video is the 3D representation of the space, of the control space. So that's what Hanley is seeing as he is moving the robot. And as you can see, he just puts his hands in front of his face. He reaches in front, he grabs it, so he grabs the arm, and the robot starts to move. And what we do, we are not controlling each limb directly, one by one. What we do is we control the end effector, or the tip of the robot, in order to, well, go to any position. So as you just saw, you can control not only the position, but also the orientation of this end effector. This end effector is basically the gripper now, as you are gripping it or as you're moving it. You can move it in all directions, basically X, Y, Z, roll, pitch, yaw, with no problem whatsoever, very easily. And you just move it up, down, and when you're ready, you just drop it. The system is designed for it to be automatic only with hand motion, but right now, for the purposes of this demo, when she is doing the grasping herself. Some of the interesting things in this interface is that it was designed to be very seamless in operation. So you only need 10 minutes of training, let's say 15, and you can grasp it and move it around fairly easily. And it's also safe in the sense that if there were to be a problem, rough motion or a crash, well, the robot will just stop. And that helps us to make sure that everything will be fine in a real operation. Our interface was designed to be used in long distances, as I said in the first demo. That increases delays and jitters. So what we try to do is that even when you have long distances, it can be used fairly seamlessly. And it's designed to be used in nuclear environments or nuclear operations, specifically for the task called glove box operation. Being the glove box, basically a box with some very thick and long gloves where a human just puts his hands and manipulates dangerous substances. So this robot would replace that human and the direct contact that human will be taking, which is dangerous at the end. So we're trying to make not only all the operations better and more efficient, but also safer for the human operator. Yes, you can see handling is going to be doing this a little bit more, grasping, moving the bottle around, up and down. And again, if you see his handling looking at maybe his left or his upside, so moving his head, is because in the VR representation, that's where the webcam feedback is. So you can see what the webcam is streaming when you move around your head in this VR environment. So yeah, as you can see, well, you can just put things that are easily movable. You can just move them around. And this time handling, just move it a bit more far to the right. Well, he's just going to continue with the other bottle. And if you have any other questions, well, or questions in this session, please come back to us. Hanley is going to keep doing this for a while, but we're more than happy to answer any questions, maybe discuss or well, get anything from you guys. And Paul has a question. Paul, thank you very much for your question. You're asking, great work, thank you. Would it be better to use by VR trackers to track the hand position and orientation while using the glove? Well, Paul, thank you very much for your question. That's a great question. It depends. Actually, the first iteration of this work and many others that we've done with our collaborators do use the controllers. It is technically easier in the sense that it comes integrated. The accuracy can be very similar to maybe better in some motions, so you're right there, especially some orientation motions. Those are more accurate. The advantage of only lead motion or just natural hand motion is that you don't need to grab anything. You don't run out of battery in your hands. And that is one of the advantages. But yeah, you're definitely right. Other trackers or other controllers also have some advantages. We only have this one because we think it's more intuitive. And some people just don't like the controllers. I personally like them, especially the ones from Valve and the Oculus. But it's something that to each its own. Paul, thank you very much for your question. I hope this answers it correctly. If not, then come back and just ask us some more. Thank you. Yeah, it's very tricky for these hand tracking interfaces or technology. It's been roughly a decade where we started doing more, well, we as a research community, from machine vision to 3D representations to have a better grasp on better tracking. And yes, sometimes the real physicality of an object is quote unquote better, but then again, we're researching into how to make it, if not equally better, maybe a viable option when you cannot have or you don't want to have the physical devices. If you have any questions, please pop them in the chat. We're more than happy to reply. I'll maybe tell you some of the problems that we've had. Well, it's very interesting when you design a robotic application. It's very popular to use software and operating systems such as RAS. That's very useful, very interesting, and very complex as well. This is designed using RAS, RAS1, for controlling and connecting interfaces. However, many times when you go to industry and you try to apply and to optimize an application, you need to go from a generic solution to a more bespoke or more custom solution. We've been in the middle in the sense that we want to improve the performance, both the networking to both put more capabilities to the system, but semi-customized, but was being in this ecosystem of ROS. So that's how it's done and how I've used it for quite some time now, this interface. When We're trying to improve it to put different networking capabilities similar to what, well, you are seeing here in StreamYard or in Zoom, what you would call newer and more advanced networking protocols. However, there's a limit between what you can have with a cable or with a Wi-Fi connection. So that's where we come in. Where technology is not enough, we need to do research for the control and estimation part, and that's what we do. So thank you very much, Han-Lin. As I said in the first interface, in the first demo, using VR in and out for a lot of, well, more than 10 to 15 to 20 minutes tends to be tiresome. So we're trying to trust our time in the demonstration. But if you have any questions, please come back to us. We're here, well, for a whole another hour in another 2 demos, plus in the Q&A now. So please, if you have any questions, we'll be looping this video of the VR representation of what Han-Lin sees usually in the VR headset. Please get back to us. We're more than happy to talk, chat, and discuss. Hi, everyone. Thank you again for joining us. If you have any other questions, we'll be here, just connected. We'll reply to any questions, either through the chat or myself. And we'll be here for a couple more minutes. If you want to just chat or discuss robotics or these interfaces, we're more than happy to do that now. And if you feel some questions are not answered or you want to just go back to them, we're more than happy to just keep going and discussing. Don't worry, this is a discussion, and we want you to be included. Hopefully, in next iterations, we could be in the same location. But please, if you have any more questions, please come back to us. We'll keep looping the video. Yes, thank you very much. So thank you everyone for joining us in the second round of our demo. We'll be here another hour, but we're now going to restart our equipment. We'll be back with you in, well, 10 minutes. If in any case you still have some questions, or you want to chat, discuss robotics, even VR or design of interfaces, controllers, whatever you want, please feel free to pop them in the chat box. Yes, we're here in Manchester University. If anyone is interested, we'll be here another hour. Thank you very much and see you in 10 minutes. Yes. Hello, everyone. Welcome to the University of Manchester. We're here in the Sackville Street building, together with my colleague, Hanley New. I'm Erwin Lopez, and as supporting staff, we have Neil and Wimshi, PhD students. And today, we're going to show you some of our work in control estimation and human-robot interaction that we've done inside the RAIN project, called Robotics and AI for Nuclear. We're going to showcase some of our outcomes, especially one that is a VR-enabled teleoperation interface, where we're going to control a robotic industrial manipulator with our bare hands and in a VR simulation. So let's come with me. I'll show you our setup. So hi, everyone. This is our setup. As you can see right here, we're going to control this robot. It's from the company Universal Robots. It's the UR5. It's equipped with a gripper or a grasper from Robotics, Robotic Q. And what we're going to do today is to move this robot around. And it's going to grab these bottles or these objects to move them around and change them from position and orientation inside what we call the workspace. And together with our robot and our workspace, we have two webcams, one positioned here on top and one on the left side. So the operator has more information about what we're doing and how the robot is moving in space. So that's what we have here in our setup. Please remember it. And now I'll show you our user control interface. So we are here with my colleague, Andy New, and he is going to showcase the interface where we use a VR headset, similar to what we use in gaming. And in here, he's going to see a VR 3D simulation of the environment that I just showed you. He's going to see a virtual robot with a gripper. And what he's going to do is he's going to control that with his bare hands together with this sensor that you see right here, called the leap motion. What he's going to do is he's going to just reach in front and grab the robot around and move it in the simulation so he can move it in real life. So, Andy, whenever you're ready. Thank you. And as you can see in the video, that's the VR representation of basically what Hanlin is looking at in the VR headset. So he's seeing this robot, this 3D robot, which is the basic, it's a replica of the real robot. And he has these other two panels where he sees the webcam streaming video, and that it helps him to see what's happening around. So if you see, Hanlin is just reaching in front to grab the robot, basically, and he moves it, well, seamlessly, with no problem, in the workspace. So you saw he just reached his hand in front of him, and he can just move it in XYZ, so in all positions, but he can also change the orientation. And what we're doing here is we're controlling the end effector, or the last link of the robot, the robotic arm. And we're not controlling each limb individually. We're just controlling that tip, and we are calculating all the individual positions of the robot. This interface was designed to be seamless and easy to operate, where you only need 10 to 15 minutes of training, and there you go. You can just use it. It only needs for you to reach in front of you, and as you saw in the video right here, Hanlin just looked at his right side, so he's going to do that frequently. He looks at his right side and maybe in front, and that's where in the VR world, that's where the webcam feed it's being projected, so he would see that in his view, the video. So that's why he looks into one side and maybe to the other, and then he grasps it. And this was designed for it to be automatic, where you just move it around and the motion of the robot is just being calculated and performed. and the grasping as well. However, for demo purposes, the grasping now is being done by Gongxi directly and not only by handling. However, we've done this many times, especially in long distances operations from Edinburgh to Manchester, basically, and it works basically the same. The idea of this type of interfaces at the end is that we use them to avoid humans to be in contact with dangerous substances, such as the ones you face or will handle in a nuclear application. Specifically, one called a glove box, which, as you would imagine, is a box where you reach with your hands inside some gloves to operate, manipulate, and to move usually dangerous substances, which is something we don't want for operators and our users. So this is designed basically to help us and to improve not only task performance, but to make it all safer. And I'll just answer some questions. John Jukes has a question. Hi, Juke, thank you very much for your question. John says, as you say, the operation is very smooth. Oh, thank you. Would it be possible for an operator based elsewhere for the Manchester to control it? Yes, John, we already done that sometimes. We did a demo where an operator sitting in Edinburgh controlled our Manchester robot. It was done last summer. It wasn't that easy because, as you would imagine, longer distances, longer delays, and you need to be cautious that it's at the end safe. But we've done it before. It can be done. We basically created our own VPN that allowed us to do that with Amazon Web Servers, and it's fine. Considerations, something very important. Networking wise or technology wise, this can be done. However, as you increase both the distance and you decrease the quality of the channel, there ought to be problems. There are bound to be delays, lost signals, and what we do in our research group is how to deal with that, besides just putting a bigger cable or just making the signal better with technology or with, let's call it 5G now. We try to use control, estimation, even machine learning to make the controller safer and smoother, even if you lose control signals. So, John, I hope this answered your question. If not, please go ahead and just ask something more. Thank you very much for the question. That's very interesting. And actually, some of the problems we're facing now in, well, both RAIN and other projects with collaborators, such as some in Japan and Korea, as you would imagine, it's quite challenging. And it needs to be as good as close distance teleoperation, long distance operation. But yes, thank you, John. Yeah, and Lynn is just going to be continuing to move the robot around. A couple more. This is the third time we do it today. Lynn is an expert operator in this setup. I don't have so much experience. That's why I'm doing the audio narration. But as I said before, 10 to 15 minutes. And if you don't have any inherent problems with VR headsets or motion sickness, it should be completely fine. I do have some personally, but I've used the setup, it's fine. So even me that have this problem with my eyesight, it works perfectly well. As I said before, maybe a commentary on the smoothness and the motion is that even if it is jumpy and even if some signals or some jitter can be seen, it's designed for it to be safe, in the sense that if there's a sudden motion or if there's a problem or a crash, the robot will stop, meaning that it will make, well, the operation safer in the sense that it doesn't go out of control, which unfortunately does happen in some applications for other controllers. However, the robot itself is designed to be safe in the sense that it has a lot of fail-safe, so we are working with the UR5, and that's what we can do with this. Yep, so we'll show you the VR representation with a video. This is what Hanley would see, or basically what he's seeing now in the VR headset. And as you can see there, you just move it around, and yeah, the Iron Man helmet, it's the viewpoint of Han Lin as he moves the robot. And as I told you before, in this right side, or what you see there in the bottom on the right side, are the panels where the webcam stream is being shown or overposed, basically. That helps you know more about the interface, sorry, the workspace, because quite clearly, even if you have a good simulation of the robot and even a good simulation of your work environment, you are not completely sure of the position, orientation, and anything really, if you don't have high quality sensing data, which is something that we can achieve with these webcams. Although, of course, it's a little bit challenging to estimate depth, with 2D webcams. So that's why some of our research is how we can integrate 3D data like point cloud and 3D models to improve user feel and user operation. So we'll keep looping the video for a couple more minutes. Han Lin is now resting because, as I said before, we've done this now 3 times, and we're trying to have the demo time for him putting in and out the helmet. Not so long. However, we're happy to answer any questions. If you have comments, you want to have some discussion, please feel free to pop your questions in the chat box. We'll be here. Either I reply or my colleagues here in the operating center will do that as well. But yes, please don't be shy of the name, even if it's something basic of how does it work, how does it work, is it that easy as it looks? Hopefully it looks very easy. It means that we did a right job, we did it correctly. Actually, it's not. It's quite difficult, and it has a lot of complexities, both scientific, but technical and mathematical. So please go ahead and put your questions in the chat box. Hi everyone, it's me again. We'll keep looping the video a bit more. We have around 10, bit more minutes for more Q&A. If you have any questions, comments, please feel free to pop them in the chat box. Again, we're more than happy to discuss robotics, AI, machine learning, control, estimation. Any questions that you have either to start in robotics, start in engineering even, or, well, what we do, that is research, that is quite challenging, but something that we are very passionate about doing and talking about. So please feel free to pop some questions in the chat box. We're here. Just don't worry. Whatever you feel you want to express, just pop them here. Yeah, I guess 10 more minutes. Yes, so thank you very much. Hi, everyone. It's me again. Thank you very much for joining us in our third session of the day. Right now, we'll just restart our systems and have a cool down period of around 5 to 10 minutes. And we'll be back at 5:30 to have our final session of the day. Hopefully, it's as good or even better than the other ones. And please join us in a couple of minutes. If you still have questions, doubts, or you want to discuss something, we're still going to be online, but we'll just show a banner as we get ready for our next demo. So thank you very much and see you all soon. And here we are. Hello, everyone. We're here in the University of Manchester. Thank you for joining us in Sackville Street building. This is our fourth demo of the day. Welcome. We're here with my colleague, Dr. Hanlin Neil. I'm Dr. Emily Lopez. And in the supporting crew, we have Neil and Wenxi, PhD students. And today, we're going to show you some of our work as a control, estimation, and human-robot interaction team here in the University of Manchester. And some work that we've done for the RAIN project, which is called Robot and AI for Nuclear. We're going to showcase a VR-enabled user interface to control and manipulate an industrial robot, which was designed by Dr. Immo Lang. So come with me, I will show you the setup. So, hello, I'm here. So this is our setup, the one that we're going to show you today. It's a robot or industrial manipulator from the Universal Robotics company. It's called the UR5. And together with the robot, we have a gripper or a grasping device from the company Robotics, the 3R. And together with these two devices, we're gonna reach and grab these bottles, and we're gonna move them around what we call our workspace. So it's all this wide table here. And to add things to our setup, we have these two webcams, one here on the top and another here in the left side, that give additional information to the operator so he can know better what's happening here in our setup. So yes, please remember what we have here, the robot, the gripper, and I'll show you now the thing we designed, which was the VR interface. So we are here with my colleague, Hanlin New, and he's going to showcase what we designed, which is an interface where we use a VR headset, similar to what we use for gaming. And what he's going to see there, it's a VR 3D simulation of the environment I just showed you, meaning that he's going to see a virtual robot, a 3D robot, and a gripper, and he's going to control it with his bare hands. He's going to reach in front, and with this sensor right here, it's called the leap motion, the position of his hands are going to be tracked and recorded so he can just move the robot around. So Hanlin, whenever you're ready, thank you. So as you can see in your screens, that video you just saw is what Hanlin is looking at inside the VR headset, which, as I said before, is a 3D representation of the arm with the gripper. And these other two panels are the webcam streaming interface, or what you can see in the webcam. And now Hanlin is operating the device already. We've done this 4 times today. He is quite an expert using the interface. However, it was designed to be seamless in this operation. So 10 to 15 minutes of it, it's enough. So you saw, Hanlin is reaching his hands in front, and he grabs it. So when he closes his fist, he starts moving the robot around. You can both move the end effector, so you can move it in all X, Y, and Z position, but also orientation. What we do here is that we are controlling the end effector position and orientation, meaning the last link of the robot, we control that one, not each link directly, but we control that that link, and we automatically grasp and close and open the reaching device. It was designed for it to be automatic, meaning that Hanlin just moves his hand around and he can open and close it, and he just controls the gripper as well. But for the purpose of this demo, Wenxi is the one operating the gripper. As you can see, you can move the robot in all positions. We use control and some mathematics in the middle for us to control the position of the robot, the end effector, and all the other positions of each limb are calculated automatically, and they just move around as handling requests. As I said before, seamless operation. Oops, nothing is perfect. Of course, the gripper and the force that the gripper applies is static, meaning that once it has the set point, if you were to just move it or push it, it would just open itself or fall, because that's something inherent to the gripping. I will talk about it later. But something important is that we designed this interface to be used especially for nuclear decommissioning or to replace dangerous interactions between humans and nuclear substances or dangerous substances. Something that happens right now in applications such as the glove box. This means that, as you might imagine, it's a box where an operator or user puts his hands on some very thick gloves to operate and clean and wash or do any maintenance of devices in a nuclear power plant. But with this, we want to avoid that very hazardous operation, because of course we want to both improve a task operation, but also improve the safety overall, and well, have our human operators happier and safer, of course. So yeah, handling is just moving around the robot however he pleases. You can change the orientation with or without the gripper being closed. It looks very easy, looks like a game, and it feels sometimes like it's, it's just a simulation. However, we are connecting these VR interfaces together with the real world, which is also extremely challenging, in order to have a seamless and useful interface. An additional remark, this was designed to be used in land operation as well. So right now we have everything plugged in with cables. However, we've tried this interface before between the likes of Edinburgh and Manchester, so long distances, with different speeds. As you saw now, handling just moving the robot in the orientation, he just tracks his movement. And as you see in the video, that's what he sees when he moves the robot. You can just see the simulation just moving in and out. And the Iron Man helmet, that's his views, that's his viewpoint. As I said again, it's very easy to use and quite seamless, the operation. And it's also designed to be safe, meaning that if we were to have an error, hopefully we don't, but if we were to have some mistake or some power outage or some signal lost, or a crash, the robot would stop because it's designed to be safe and to avoid crashing down with any obstacles. So Hanlin is going to do this a little bit more. He's now an expert. He really likes, well, just showcase our work in control and estimation. But if you have any questions, comments, or you want to discuss something about control, robotics, user design interface, we're here for you. I'm happy to discuss this. Yep. The position that the robot, that you want the robot to be, in the orientation you want it to be. So the only thing that Hanlin is doing is basically guiding the robot into where he wants it to be, and facing into which orientation. And with our models and with the tools that we created, we make the calculation of how much each joint should move. A small remark about this is that tight control is more difficult for position control, like the one we're doing, but it seems to be all right. And we have one question. Simon, thank you very much for your question. Is lag a problem? Lag is a problem, meaning, or at least how we describe lag is the timings between each control signal. It's a problem. Usually, and this is a bit of technical issues, usually a controller should have a set frequency rate or a control rate. However, it's different to the rate that you have as a human in your eyes and your other senses. And on top of that, it's different to the rate of the video interface. How many frames you have here in your headset, and how many frames you have also moving the hand, which is the sensor rate. So yeah, dealing with all these rates and that the internet channel is not always deterministic, it's a problem. So that's something that we try to improve in our research. But yeah, definitely it's a problem. If you just plug things up and just put them, you would see that it works, meaning that you are moving things around, but the performance is quite laggy, brutish, and not very consistent. But we're trying to improve this. However, I hope you see that it's fairly smooth and fairly seamless, although, of course, there is some vibration there. Simon, I hope that answers your question. If you have any other, please pop them in the chat. Thank you. Oh yes, lag is a problem. And it happens in a lot of modern applications. Just talk about gaming, talk about any streaming. Unfortunately, the problem that we face now is that we are controlling a real robot. So we cannot do what you do, the tricks that you do for streaming services, where actually there's a lag between what you're seeing here and what I'm doing. So there are 2 or 3 seconds of lag. Right now, we need to be them for control purposes. It needs to be quick and deterministic, meaning that every time I see what happens in real world, I need to be picking that signal and I need to be controlling that in what you would call real time, or at least a close gap. And that's extremely challenging. It's not as much as just streaming videos with 2, 3, 4, 5 seconds of lag, or even a Zoom call, which you also have lag. In here, we are facing different problems, and it's not easy. No. Any other questions? Please pop them in the chat. We'll put the video of the VR interface whilst handling finishes with the operation. As I said before, this is the 4th time we do this today, and although VR headsets have improved immensely in the recent decade, it gets tiresome for him. And that's a problem that all the VR applications face, but luckily our interface is not that taxing. However, we need to be gentle with our operator handling. So yes, a bit more about the VR interface. And as I said before, if you notice handling moving his head to the right or to the front, is where these panels have the webcam video feed being shown. So that's why basically he just reaches, he looks to one side or the other to see where it would be in real world, and then he does the motion. And this is particularly useful to estimate the depth and to really know what it's inside your environment. Because no matter how good your model is, you need to have better awareness of the real environment. And that's achieved using sensors as the ones we have. So yes, thank you very much, Hanlin. Yeah, he's just taking a rest now. We'll keep looping this video of basically the VR interface of what Hanlin is looking in the simulation, which is also connected to the real interface. And if you have any questions, please pop them in the chat. We'll be connected. We'll be here. We're not gone. Please don't go away as well. If you have any other questions about control, robotics, even other types of robotics, not only manipulators or robotic arms, but mobile platforms, even engineering, we're more than happy to answer any of your questions. And maybe we don't have the answers, but we can just comment and we'll have a discussion, which we are more than happy to have, even in a YouTube chat. Please don't be shy, and we'll be here. Thank you very much. And we are back. And we have another question from John Jukes. Hi, John. Thank you for your question. John asks, in industries that don't already use VR, but could, which potentially could be all of them, what do you think are the best ways to introduce the tech to them? Well, that's extremely interesting. I will put that into two perspectives, maybe the business one and the technical one. From my perspective, the technical one is the one we do, where it would be good if you have some type of demo, even if it's not connected to real world, but it's like quote unquote game around the application of this technology. Meaning that, of course, it looks very shiny, very nice, very pretty. However, when you apply this type of technologies, you're thinking about what's the use case and what's the benefit. You need to create this this business case, let's call it, not that has both technology benefits, but also commercials. In the commercial ones, I'm not going to go there. But for instance, many companies, what they do is have a small demo or a demonstrator of what it would be like if you have this interface. So if it's, even if it's VR or AR, augmented reality or mixed reality, where you, for instance, are tagging objects and then you go around and see the information you would have, and maybe you have some estimations of time reductions, cost reductions, improvements in performance, which is primarily the benefits of VR. You are replacing physical setups and gear that wears down with just sometimes just motion and just VR virtual designs that you can just reuse. So that is one thing that you can have, basically a small demonstrator of the benefits, and that's something that we do here in Brain, meaning that we just showed you, hey, this is what could look like. Of course, we need more work. It has some quirks, but see what you can do and what you can try with this technology. So that would be my advice. Just try it and see where it goes. But maybe somebody else in chat has other opinions, or maybe a better answer from the business perspective. But John, thank you very much for your question. I hope this answers it. If you don't feel that it's enough, well, please feel free to just ask again. Yes, and I will keep showing the video because it's very fun. We never get tired of it. And as a small comment before just continuing, we are continuously improving our ideas and our setups. This is roughly the third iteration of the setup. We've tried to extend it to use other robots. We tried to extend it to use other VR headsets, other interfaces, because, of course, this connection between human and robot, human and machine, has a lot of depth, not only from technological, but from societal, even philosophical perspectives. And we try to go around researching this to create new and better tools for industry and the community itself. So yeah, just a small parenthesis of what we do here. Yes, we'll just keep looping the video. If you have any other questions, please pop them in the chat. We're more than happy to talk and just answer any questions you have. Thank you very much. Hi, everyone. It's me again. Thank you for joining us. If you have any other questions, again, feel free to pop them here. We were just showcasing some VR interfaces for teleoperation of industrial robots, seamless and safe teleoperation. Please, any other questions, comments? If not, I will just take this opportunity to thank you all, and thank you also the UK-RAS Network, also the RAIN project, and many of our collaborators in RACE, in other countries such as Korea, Japan, and basically all the people here working in Manchester and other universities who have put together a lot of effort into creating this, and basically working with us to improve interfaces and control. All this for the benefit of, well, not only industry, but society itself. And thank you very much for joining us. If you have any other questions that we cannot reply here now, again, you can just send us an email. We are here in the University of Manchester, the Control Estimation and Human-Robot Interaction team. We're more than happy to chat. If you have any doubts, if you are interested in engineering, robotics, or well, control itself, we're always happy to get more people together and work in these very interesting problems for the future society, basically. So yes, thank you very much. We'll just be around. If you have any other questions, we have, well, 5 minutes, but we'll just be around. Yes, feel free to pop something here. So thank you very much. This is our team. Neil, Wenshi, as you know, Dr. Hanlin, and me. Thank you very much for joining us. This is our last session. This is a wrap. Thank you so much for joining us, and hope to see you soon, if not next year, well, before. And yeah. Thank you, everyone. Bye. Have a nice and pleasant summer.